From this video, I'll explain you the solution of Ukmt 2024 of IMC. But maybe I may start from the number 11. If you have any question from number 1 to 10, please feel free to leave any messages or comment on this video, then I'll answer it to you. So let's go for the number 11. Here, a picture together with this frame makes a square. So percentage of area. So we need to know the whole area and also covered by the frame. The whole area, because it's the square, so 80 by 80. I don't calculate it. You will tell I don't calculate it in the middle of the calculation because it causes a little bit of mistakes sometimes and it takes more time. So I rarely calculate it. Sometimes, of course, I calculate it, but most of the time I leave it just like that. And here by the frame, this one, the width is 4. So 80 by 4. And this one should be 80 minus 8, so 72. So now we can tell 80 by 4, 72 by 4, but each of them has 2. So 2, when I decide not to calculate this means I think this will be more simplified, like canceled out. So I will factorize this one, like 80, 72, 8 by 10, 8 by 9. So here we will say 2 by 8 by 4 and 10 plus 9, 19. So 8, 10, 10. So 19, 100, which means 0.19, 19%. Number 12, length of the line segment mark X. This is the question of the Pythagorean theorem. So we can start from the first right triangle here. So square of 1 makes the square of the hypotenuse. We can say X. So x squared is 2, which means x equals square root of 2. Square root of 2 is the number. It is the just normal number like 1 or 2 or 3, but just we don't know what it is. So the definition of square root of 2 is the number. When we make it square, it becomes 2. So maybe some of you may know square root of 2 is like 1.414 is something like that. So 1.414 times 1.414 makes it almost 2. So x is the square root of 2. So let's find this one. Square root of 2, square of square root of 2 is 2. Square of 1 is 1. So here square root of 3. Square root of 3, when we make it square, is a 3, and 1, 4. So here square root of 4. So we find the pattern. So square root 9 means when we square a number becomes 9, which is 3. 13. When I increase a certain number by 20%, I get twice as much as when I decrease 20 less than the number by 20. So we don't know what is the number. Let's make it x. When we increase a third number by 20%, it becomes 1.2x. If we decrease the certain number by 20%, it becomes 0.8x. We need to understand this well. Always we start from the number itself. So always we have the number x. And we want to increase by 20%. Actually, from the context, 20% of that number. So x plus 20%, 20%, yeah, let's make it 20%. 20% 100x. So when we make like factorize it, 1 plus 0.2 makes it 1.2x. That's why if it becomes minus, like decreasing, then it makes 0.8x. So this is how it works. So you don't need to calculate from the beginning always. Just you need to get the sense of the 20% increase make it 1.2, and 10% less at 0.9. 100% increase means 2x, something like that. So here, let's make the sentence into the algebraic expressions. Then increase 1.2, I get make it equals twice as much as it's double. This is the double of something. So double of something. What is that something? When I decrease 20 less than the number by when I decrease 20 less than the number by 20%. So 20 less than the number. Decrease by 20%, we know this is 0.8. The 0.8 of that number. So here, that number means 20 less than the number. So this is the one. So you can solve it. 14. Going clockwise around the quadrilateral interior angles at the ratio 6, 7, 8, 9. So we can set it 6x, 7x, 8x, 9x. When we know the ratio, we can always put x because to find the actual number. So we don't know how it looks. Let's say like this. So 6x, 7x, 8x, 9x. So we know when we make the sum of all these four angles, it makes it 360 degrees. So when we add them, it's 30x makes it 360. So x is 12. So 72 degrees, 84, 96, 108. 72, 84, 96, 108. So now we know there is none of any congruent angles there. So it cannot be parallelogram, it cannot be kite, and we don't have any right angle, it cannot be right angle. Cyclic means the polygon can be placed in the circle, but not like this. All the vertices should be on the circumference. So let's say like this. This is a cyclic quadrilateral. So the quadrilateral has the property of the opposite angle. When we add them together, it should be 180. But actually, we cannot make any 180 from these opposite angles. So this is not cyclic. So there is only one more option, which is trapezium. But we need to know why this is trapezium. Trapezium has the one parallel pair of sides, but we don't know what is the other side. Maybe it looks very much different like this. But whatever it is, when we have two parallel lines and transverse like this, and when we have same side interior angle, always make 100 together. So here, let's say we couldn't make 180 from these opposite angles pairs, but now we can make 180 with these adjacent angles. So this is how we can decide that this quadrilateral becomes the trapezium. So this is the trapezium. But actually, you know, if you don't solve this out, before we solve it, we could find the answers too. It says this is the like adjacent to 6, 7, 8, 9. We know that. So here we can tell there's none of any congruent. So we can remove this quadrilateral who has any congruent angles pairs. And also we can tell this and this is opposite angles and this are opposite angles. But when we sum them together, it's 14 and 16, which are not congruent. Because 180, if we make the opposite angles like 180 and 180, both 180 is congruent. So this is not cyclic. And right angles, actually we need to know. Trapezium, we need to know. Here, for example, if we see these two adjacent angles pairs, this is 13 and this is 17. So this is not congruent, which is not 180. But if we make 15, 15, this is congruent. So actually we can define this quadrilateral becomes maybe a trapezium. This one, I think we need to calculate as we did before, but yeah. And 15, Carrie, Barry, Rolly, 4,000, Barry, Rolly, Carrie, 2,000, Carrie, Rolly, more than Barry, 3,000. So let's make them together. Actually, this type of question is quite popular in this type of math competition questions. How can I say this is quite cyclic? Cyclic, yeah, because CB, BR, RC. So this becomes a circle, CBR, and make the relation of each of the two. And in this case, we can make we can find their relations easily when we add them together, or maybe multiply them together, something like that. But in this case, I think we can add them together. So here, 2B, 2C, 2R, BCR, 5,000. So BCL makes it 5,000. So here, the question is about Rolly. But here, C plus B is R plus 4,000. So we can put it here. R plus 4,000 plus R makes it 5,000. So you can find the Rolly's weight. And let's go for the next one. The factorial notation is not easy, but not difficult. When it becomes like the larger number, it's quite difficult, but you don't need to memorize or something the evaluation numbers. Just we need to understand what is the concept. So factorial of n factorial. This is the definition of factorial. But here, when we divide by 5, we know always the answer, if it is divisible by 5, always the last digit becomes a 5 or 0. When we divide by 2, the last digit should be the even number. When we divide by 3, the sum of all digits should be divided by 3, you know? For example, 1, 1, 1 can be divided by 3 because 1 plus 1 plus 1 is 3. 2, 3, 4 divided by 3 because this becomes 9. But likewise, 3, the multiple of 3, actually multiple of 9 has the same character. This is divided by 9 because the sum of the digits are divided by 9. And maybe 8, 1, 9 divided by 9, also divided by 3. Always the multiple of 9 is multiple of 3. So this is the, and sometimes you can make the 1, 8, 1, 8, 1, 8, and 1, 8. Each of them are divided by 9 already. So you can define like the 1, 8, 45. Yeah, it can be divided by 9. So this has the character. And divide by 4. Yeah, since I start, let me finish. Divide by 2, the last digit should be the even number. Divide by 4, last 2 digit should be the multiple of 4, like 1, 1, 1, 1, 1, 0, 0, 4, 5, 6, and 0, 4. We know this is the multiple of 4. Or 84, of course, is multiple of 4. So last 2 digits decide whether this whole number is the multiple of 4 or not. And likewise, multiple of 8 decide by the last 3 digits. So for example, 1, 2, 3, 4, 5, 6, 0, 0, 8, or 0, 8, 8. Yeah, this makes the whole number becomes the multiple of 8. 8, 8, 8, of course, should be. So anyway, this is very easy guessing of the multiple of the specific number. But here, it asks us about the remainder, not just the multiple of something. But anyway, what I'm saying, just we can consider only the last digit. We don't need to know whole number. So last digit of 1 factorial is 1. 1 times 2, 2. Times 3, 6. Times 4, 24, but we don't need 24. We need only 4. Times 5, last digit 0, 0, 0, 0, 0, 0. So the last digit, we consider only last digits here. And the sum of the last digit also decided by the last digit. So here, the sum of this, the factorials, becomes 3. The last digit is 3. So when the number who has the last digit of 3 divided by 5 make the remainder of 3. And the next one, you know, we don't have a lot of this type of expression. This makes you always confusing. 4, 3 squares. This is like 3 layers, but most of our expressions are only 2 layers. This one, this is a little bit tricky because this looks a little bit higher, so, but not this one. This also like this. So let's think about the definition of these exponents. And when we have the bracket, it's better to consider it the first before we move on. So here, 4, 9. That square is applied to only 3. So 4 to the power of 9. And this one, as I told you, this is like this. Because I told you we need to consider the bracket first. So if you want to make it 64 squares, you don't need to do that because this one, we need to stick on this base 4 to make them simpler calculation. So this one, we have 4 cube twice. So 4 cube times 4 cube. This means twice. Twice of what? Twice of multiply. So 4 cube times 4 cube makes it 4 power of 6. So 4 to the power of 9 divided by 4 to the power of 6 makes it 4 to the power of 3. And negative 1, comma 4 reflected in the y-axis. So negative 1, comma 4. 1, comma 4. So this is Q. Q is reflected in the line y equals axis. Y equals axis make it interchange between x and y. So here are 4, comma 1. And R reflected in the x-axis, or x stays there, and y becomes the opposite. So 4, comma negative 1. So what is the area? I didn't know. So like this. Actually, because this looks the trapezoid, but we need to decide which is the easiest way to find the area. If I were you, I may just make the calculation like this. Because we know this is 5 and this is 5. So from 25, anyway, this becomes half first, and I'll take this out. This one, 3 and 3. So 2 over 9. I think this is the one. And number 19, non-zero numbers in each row and each column and each diagonal multiply to give the same product. So whatever you multiply, maybe it's the same. Like multiply here 6x, multiply here 6x. Oh, so which means here should be 1. Oh. And this one 6x. So this is x over 2. 6x. X over 6. No, x over 3. So this makes each row to make it same 6x. So here, so this should be 6x too. So 6x squared should be 6x. So x squared 36x. X squared minus 36x becomes 0. X should be 36. A shop sign says t-shirts 3 for the price of 2. If we, let's say, if the price of the t-shirt is X, then we need to pay 2X. Equivalent to the saving of 5.5 on each t-shirt. So X minus 5.5. But anyway, I get 3 t-shirts, so this is a 3. So this makes X 16.5. But you know, there is the they didn't ask us the price of 1 t-shirt. It asked us how much money we need to pay. So we need to pay of the price of 2. So the answer 33. And number 21, side 4 with 4 identical semicircles drawn, shaded area. So here, this is the side 4. Side 4 of square, yeah. So this is the one. Let's think about it. So we don't know what is the radius of these semicircles, but they are together. And when we draw the line, the diagonal here, this is the tangent of the circles. When the line tangent to the circles, it makes the 90 degree like this. And now what do we know? And because this is very symmetrical shape, so this is 2. You're right. So this is 2 and this is 2. So this is square root of 2 by the Pythagorean theorem. So now we understand that it's square root of 2. So let's make all together like this. Then now let's forget about the largest squares. Let's see only these squares with these black lines. Then the line has, each segment has 2 square root of 2. So 2 square root of 2 times 2 square root of 2. This is the whole, the area of this. But we want only this shaded area, so we need to take out this 4 quarter of the square, the circles, which means 1 circle. And it has radius of square root of 2. So I'll take out just 1 circle. So pi r squared. You know, when you multiply them together like this, you can multiply with the same shape. I mean, like you can multiply 2 by 2 and square root of 2 by 2, for example. So n2 pi, 4 square root of 4 minus 2 pi, so 8 minus 2 pi. And 22. When a cube is cut into 2 pieces with a single plane cut, polyhedra. Okay, so here, let's say if we have this type of cube, and let's cut it out. If we cut, when it says we cut by plane, we cut by this straight flat plane. So for example, if we cut like this, that cross the shape of cutting is just triangle, which is plane. So in this case, we have this smaller solid and this larger solid. Let's say this smaller solid has the 4 faces. So it has 4 faces. We can make 4 faces. And the other, this larger one, has 1, 2, 3, 4, 5, 6, and plus this is the triangular, the face, which means 7. So at this moment, we can make the polyhedra with 4 faces and 7 faces. And let's make something else. For example, let's make it, cut it different way, more, let's say like this. This is also, I made the quadratron, which is plane. So if I cut it like this is still satisfy the condition. So in this case, it is a smaller part, is 1, 2, 3, 4, 5. So we made polyhedra with 5 faces. And the other side, 1, 2, 3, 4, 5, 6, 7. Oh, still 7. So we can make 5 polyhedra. Why I keep saying tetra? And also we can try another one. It was, how can we decide to cut different way? Maybe here. This is also hexagon, so which is plane. So in this case, if I cut it like that, so this part is the smaller one, that part could be the larger one. So the smaller one could be half. It's so confusing. So this is the what we have. Right? Yeah. So upper part, lower part, 1, 2, 3, 4, 5. Oh, I made only 5. So this is not anything new. And we can make what can be the different way? If I make it pentagon, let's say like this, then like this. So let's say the red one is not shown. 1, 2, 3, 4, 5, 6. So in this case, this blue part is 6 faces. The opposite part is 1, 2, 3, 4. 1, 2, 3, 4, 5. Is it 5? Yeah, 5. I think that's the 5. So this one, at this moment so far we make 5 and 6, but we couldn't make it 8. But what if we can make? Actually we cannot make, because so far we explored the cutting of this cube, but we can tell we can add one more face, like this cutting face, but other than that, others are all the part of the cube. So anyway, maximum the cube has these 6 faces, and we can cut just like a plane, just one plane like this. So we can add only one more plane. So in this case, 8 means 6 plus 2, but we can make only one cut, so this cannot work. So the E is not make sense. And 23, that is P and PA, PO same, the ratio of radius of the circle, radius of the semicircle. Oh, okay. So there's a small radius and large radius, we need to find it. So like this. And if we continue, like if we draw the line from O to P, then this makes this radius R, radius, no, this is not radius R. Actually, the large radius is this one, so maybe this is R minus R. This is R. And this is half of the R. When the triangle is isosceles triangle, and this is vertex, that when we draw the line, this perpendicular line or bisect line, actually it always divide by 2. So this is all over 2. So here all minus r squares, again Pythagoras. Actually there are a lot of the question of Pythagoras, all over 2 squares. So when we expand this, r squared to r squares over 4. So r squares, yeah, I don't like fraction. Let me multiply by 4. So 4r squares minus 8rr minus r squares equals 0. So is that it? It's not. Why it's not simple? I said it could be simpler. R over 2, but nothing wrong. So, yep. So, no, this is all. I said this is small r, so I was confused why I cannot make any factoring. So all 3all minus 8all equals 0. All is the length, so it cannot be 0 in this case. So we need to, we can see this is the expression to make it 0. So 3all minus equals 8all. So r equals 8 over 3r. But the question is radius of the circle to the radius of the semicircle. So, but we know this is the one, all 2, 8r over 3. So when we make it 3, and 24, regular hexagon, and 1/4 of the area of the hexagon. Walk around the hexagon R to P to Q. Okay, they start from P and clockwise J and K counterclockwise. So in this case, how can we make the distance? J walk to distance K walks. Okay, let's see. So now we know this is 1/4 of the total. You know, hexagon, the exterior angle of the hexagon, 360 divided by 6. So this is 60. So this is, no, what is this? The 120 altogether. So divide by 2 is another 60. So this is 60, this is 60. So let's make like this, let's say. No, let's make it like this. So the hexagon has the center of all diagonals pass, like intersect. Each of the triangles are all equilateral triangle, all equilateral triangle. So now we know we have 6 equilateral triangles all together there. So let's call the one triangle area as S, then 6, this hexagon area could be 6S. So this is a 6S. So let's make it like this. This is half of the equilateral triangle. So this is half of the S, this is half of the S, this is half of the S, this is half of the S. So this is 1S. So only this part is 1/6 of the total, the regular hexagon area. So 1/6, 2/12. We need to make 1/4, 3/12. So we need another 1/12. So this should be the 1/12. Let's see, this is another 1/4. Let me write it. This is not 1/4, sorry. This is S, 1S, this is 1S. So this is 4S, because all together 6S. 4S. So how can we divide by them to make 1/4? So let's say let me put it x. Then s plus x over 6s make it 1/4. So this is the equation. So 6s equals 4s plus 4x. 2s equals 4x. So x equals 1/4 of s. Right? So this is 1/4 of s. But this all together is 4s, and this is just 1/4 of s. So we can say the ratio of this length, we can say this all together to when we divide, this is 6s over 2, and this is 1s over 2. So this is 7 and this is 1. I mean the ratio. So let's call this x. Let's call this x 7x. So this length is x, this length is 7x. Which means that here is x, 8x, 8x, 7x, 8x, 8x, x. So J who walk around this pentagon, no, not pentagon, the hexagon to the clockwise. So she is walking 9x, 18x. So J walk 18x. The distance what she walk is 18x. What about K? Okay, 7, 8, 8, 7, so 30x. So the question is the distance of J to the distance of K. So J to K is 18x to 30x. So when we divide by 6x, this could be 3 to 5. So this is the question of this similarity, and you can like cut the polygons into smaller polygons which you can interpret. Always a triangle and quadrilateral is easier way to think other than other like more number of polygons. And 25. Gold coin is worth X% more than a silver coin. Oh, so now again X% more. So gold coin is X% more than silver coin. The silver coin worth Y less than the gold coin. X and Y are positive integer. How many possible values for X are there? Oh, so let's put this here. So gold coin is 1 plus 100X times 1 minus 100Y gold coin. So we can cancel out the gold coin because gold coin is not zero. When it can be zero, we never cancel out. So now we can find the relation between X and Y. Let's make it a little bit more easier way to see. 100, 100 minus Y. So 100 plus X and 100 minus Y becomes 10,000. So for example, now we can find the pairs of vectors of 10,000. For example, 1 times 10,000. If we make it, then Y becomes 99 and X becomes 9,900, for example. And 2 times 5,000, there's no 3, 4, 5, 6, 7, 8, 9, 10, something like that. But this is good way to find the pairs. But what if we miss something? So this is not very good way of finding the pairs. So anyway, now we are on the way to finding the pairs of the vectors of 10,000. but we can make 10,000 into these prime number factors, like 10,000 is 1,000, like 10 divided, like let's say 10 power over 4, but 10 is 2 times 5 over 4. So 2, 4, 5, 4. You know, this has the number of factors of 4 plus 1 times 4 plus 1. So this has factors, 25 factors. But among there, the 100 by 100 is not our consideration because it makes x and y 0, because it says x and y positive numbers. So in terms of the pair, not 100, there are 24 factors altogether. So as a pair, divided by 2, there are 12 pairs of the x and y. So which means x can be 12, like different possible values.